This video demonstrates how to configure the Windows processor power management settings that adjust the central processing unit's clock frequency. These settings are often set by the computer manufacturer to reduce the computer's power consumption, which may or may not be desirable for the end user. Reducing the processor operating frequency by 50%, as shown here, doubles its workload, as shown here, and doubles the amount of time it takes for the processor to complete its tasks. These are the power management settings that are described in this video. These particular settings are typical for desktops, since desktops are primarily plugged into wall outlets, whereas a laptop, it can also operate on its battery, so it has an additional setting for battery operation. The processor power management settings are located within the Power Options utility. So within the Start, we're going to type within the search Power Options and select Power Options. And this is what we're interested in. You can create your own plan, but I'm just going to modify the presently active plan, which this one is called the balanced. And we're going to say we're going to change plan settings. And then we're going to click on change advanced power settings. And then we're going to scroll down till we see processor power management. So this is what you would see for a desktop. You would have the minimum processor state. So the setting is between 0 and 100%, where 100% is as fast as the processor can go. So when you ask, well, how fast can the processor go? What does 100% represent? What you can do, if you want to see how fast your processor is go back to your Start menu and do a right-click on Computer. And then at the very bottom, do a left-click on Properties. And you can scroll down until you see your processor. And this processor is operating at 3.4 gigahertz. So when it says 100%, it means it's operating at 3.4 gigahertz. So this is the frequency at which the processor is operating at. And to speed it up or to slow it down, what we're doing is varying this frequency. And you can operate the processor a little bit faster than 3.4. And if you look at the manufacturer's specification of the processor, it'll tell you how much over you can go. And we'll actually see that on the performance monitor. We'll look at that later. So 100% for this computer is talking about 3.4 gigahertz. And then the maximum processor state is also set to 100%, which is the 3.4 gigahertz. And we'll look at the performance monitor to see how that actually looks and what it's actually doing. And then when we talk about the fan, it talks about the system cooling policy. So this is actually the CPU fan. And you have two states, a passive or active. The passive state is used mostly for laptops when it's operating on a battery. So in a passive state, the fan will only turn on when the processor reaches a certain temperature. It's more of a reactive mode of operation when you're set to passive. And the reason you do this is twofold. First, for the power savings, because you're not running the fan all the time. And second, it cuts down on the noise, so you're not listening to the fan running all the time. So an active is the fan just is running all the time. And you typically want this setting for a desktop if you're doing a lot of process intensive applications like gaming, or maybe you're running engineering applications like SolidWorks or AutoCAD or maybe MATLAB, and you just need the computer up and running all the time. So looking at a laptop, you would enter within this search bar Power Options and then select the Power Options utility. And here's the Change Advanced Power Settings. And here's Power Options. And you'll notice you have two settings, an on battery and plugged in. For the minimum processor state for an on battery is 5% processing power. And then for the maximum, you have 100%. But we could change this to be less if we need the battery to last longer. It simply means that whatever you're doing is going to take longer to get done. While it's plugged in, I just have everything set to 100%. And then for the cooling policy, when I'm running on battery, I have it passive, so the fan only kicks in when the processor gets hot enough. But if plugged in, I want 100% response of the processor, so I'm going to actively keep it cool by running the fan all the time. Okay, so what does it all mean? You've got a computer, it's got a processor. We can control how fast the processor operates by changing the frequency. So this would be considered the operating frequency. So 3.4 gigahertz. Okay, well, let's wrap our heads around what 3.4 gigahertz looks like. So if we translate 3.4 to actual hertz, and you can see that it's actually 3.4 billion. So a giga is 10 to the 9th, so you got 9 zeros, and a billion, it's also 10 to the 9th or 9 zeros. Okay, so it's a huge number, and what it represents is how many repetitions the processor can complete, or how many iterations a processor can complete within a second. If we think of in terms of a hummingbird, how many times can a hummingbird flap its wings? 70 times per second. So what is that in frequency? That would be 70 hertz. So if we typed in 70 and cycles per second and then hertz, and you can see that 70 cycles per second is actually 70 hertz. So they're one and the same. A hertz represents a cycle per second. So instead of writing cycles per second all the time, you write out hertz. We have an analogy of a bird flapping its wings. And if we increase the frequency at which the hummingbird can flap its wings, it would be a super hummingbird because it could go much faster than a regular hummingbird. Or vice versa, if we slow down how many times or slow down its frequency of its wing flapping ability, then it becomes a below average hummingbird. But guess what? If it's flapping its wings at 70 times per second, its heartbeat is around 1260 beats per minute. You know, that's pretty stressful. So if we slowed down the amount of wing flaps per second, then you know that its heartbeat will also slow down, which means he's conserving energy. So in a nutshell, that is what is happening with a processor. You could think of the processor as how fast is it beating its wings in order to do whatever it needs to do. Hope that helps. For power consumption comparisons, we'll take a look at a 60-watt light bulb. And let's say that we turn on the 60-watt incandescent light bulb for 1 hour, and electricity costs about 15 cents a kilowatt hour. So we can convert the 60 watts per hour to 0.06 kilowatt hours, and then multiply that by the 15 cents per kilowatt. And that gives us roughly 0.009 cents for every hour that the light bulb is turned on. So let's go ahead and measure a 60-watt light bulb power consumption. We're taking the 60-watt light bulb's cord and plugging it into this fixture that allows us to measure the current and voltage. So we take our 120.2 volts AC, multiply it by the 0.5 amps AC, and we get our 60 watts. I'll unplug the light bulb and plug in a desktop and monitor. The maximum rating for the desktop power supply is 320 watts. This provides additional power for any future cards that may be added to the computer, like this video card. The 90% efficiency is telling us that there's 10% inefficiency in the power supply. So if the power supply is only able to convert 90% of the power provided to it, then 10% is wasted. So with the computer turned off and the monitor left on, the monitor consumes around 12 watts. So let's calculate what that would cost. So if we take our 12 watts per hour and convert it to kilowatt hours, and then multiply that by the 15 cents per kilowatt hours, that gives us about 0.0018 cents per hour. So the computer is powered up and setting idle, and it's consuming the same amount as a 60-watt light bulb. Now I started a task that's consuming 25% of the CPU power consistently, so I can look at the current and see what's going on. And I have my power option settings at 100% for both minimum and maximum. We can see that it's 1/10 of an amp more power consumption. So if we cut back on our processor to 50%, we saved 1/10 of an amp by reducing the power option to 50%. Okay, so now let's take a look at the power management settings and how they affect the resource monitor. So we can open the resource monitor one of two ways. We either can type it in here at the search bar and open it this way, or we can go through the task manager under performance, and you'll see the resource monitor button on the bottom, and it'll also open up the resource monitor. So under the CPU tab, these are the 4 resources that it's monitoring, and we're only interested in the processes. In here you'll notice this is the maximum frequency. So that relates to, go back here, open up our power options, go in our plan, advanced power settings, we don't need that anymore. And then we'll scroll down here to the processor power management, and we've got a minimum and we've got a maximum. Okay. So this correlates to this blue line. So let's make this large. Okay, so we have this blue line here, which is, for the most part, controlled by your min and max. So right now I have both min and max at 100%. Let's move them to 50%. And we'll apply it. And you'll see it drop to 50%. Now the green is the actual processes that are executing, and it's trying to illustrate how much of the total CPU processing is going on. But you'll notice up here that our maximum frequency is now set around 50%. So what that translates into, again, if you look at your computer operating frequency, which this one is 3.4 gigahertz, and you divide that by 2, the processor is now running at 1.7 gigahertz. And if you would like, you can select the link below in the descriptions to go to this Microsoft question and answer with regards to setting the power plan like we're doing right now. And he will also describe setting 50% at 2 gigahertz CPU, setting your minimum power setting to 50%, then you're operating at 1 gigahertz. The min and max are more like guidelines, where the minimum is the low range and the maximum is the upper range. So if we would set this to 100% for the maximum, then the operating system will try to manage the processor so it's between 50 and 100%. So you can see it bouncing around, and this line is a representation of this value here, and you'll see this value is bouncing around. So you can imagine if this is a throttle of a car, the engine is going fast and then slow, and then fast and then slow. And if you took it to the other extreme where you took your maximum, made it 50%, we're going to set the maximum at 50, and then we're going to set the minimum to 10. So on this computer, we got a couple of things going on. First off, I got a process, this Corel Video Studio screen capture that I'm using to record this is actually consuming a lot of process time. So it doesn't give it an opportunity to drop. And you'll notice that as soon as I slowed down the processor, the amount of things that needs to be processed ramped up, because I imagine this is a real-time application and it needs to get its tasks done. Otherwise your video would look kind of crazy. But I've tried this without the Corel Video Studio screen capture running, and so the green was pretty much flatlined because there was nothing really taking up resources. On this particular computer, the maximum frequency and the minimum frequency, as low as they can go, is around 50%. So if I crank up the maximum to 100%, you'll notice the CPU loading drops, because those real-time application and tasks are being completed on time because the processor is running twice as fast now. So that's pretty cool. And again, you'll notice this bouncing up and down, up and down. The operating system is simply reacting to the tasks that are being executed. So you got different types of tasks, and it's a reactive response. So if you are running games, or maybe you're running engineering applications that take a lot of processing horsepower, and you want to get it done as quickly as possible and as it responds seamlessly, like in a video game, you don't like it when it's jerking all over the place, then this is not what you would want to see for your power management. You'd want to set both max and min to 100%. And you'll notice that the maximum frequency does overshoot 100%, which is your 3.4 gigahertz. And if you reference the CPU chip manufacturer's specifications, they'll tell you by how much the CPU can be what they call overclocked, where you're running it faster than what its rating clock speed is. Okay. And thank you for watching.